Hi, everyone. Welcome to the second part of our webinar series. This one focused on optimizing your AKS cluster for security and compliance. Going to go through a quick agenda for those of you who are joined and then or watching, and do a quick introduction of myself and Ray. Then we'll talk a little bit about the webinar series as a whole. And then we'll go through kind of day two. What is this second series really about, and how are we going to build on the content from the previous session? So for today's session, we're going to be focused mostly around security and compliance of our AKS cluster. So we're going to do a quick welcome and introduction as mentioned. We're going to talk about cluster setup. And in this case, I don't necessarily mean that day one, day two cluster setup, but really how are we going to, I would say optimize and add on to the existing cluster to really take advantage of some of the security features that you can have specifically within Azure as well on some of these, and then some that are going to apply broadly to Kubernetes really running anywhere. And then we'll walk through that setup and talk about why we made those decisions. So very similar workflow, I guess, as the previous session. We'll do a quick Q&A, which we won't do this time because this is not live, but we will be posting our Q&A on the web series page after the final webinar, just so if you want to refer back to those and see what some of the live questions and conversations looked like, then that would be a great asset to you. And then we'll do a quick review and talk about next steps for the following session in the web series. So if you are joining us for the first time, my name is Kendall Roden. I'm a technical specialist on the Cloudnative Global Black Belt team at Microsoft, a co-host on the Azure podcast. So obviously really like to talk. If you want to connect with me, feel free to find me on Twitter or LinkedIn at Kendall Roden, and then put the Kubernetes logo here. Obviously, Ray and myself do a lot of work in the Kubernetes space, but I've had the opportunity to work a couple of times as a shadow on the upstream team. And so if you ever have any questions about what that experience was like, or if you're interested in applying, would love to give some insight there. I'll pass it over to Ray to let him introduce himself.
Yeah, love following up, Kendall. Same team, same role, Kubernetes space, all that. And so that's my intro. Good to meet you all. I'm on Twitter, GitHub, Rayco.
Awesome. Thanks, Ray. So I want to do a quick overview of the series itself and just kind of what our objective is here. So our last session happened live on the 19th of April, 2021, and it was really about configuring your AKS cluster with confidence. And so what that means is making sure that you feel really like you have a deep sense of why you're making certain decisions around your cluster, and you get some idea of what we recommend to customers who are, we've worked with a wide variety of customers for the past couple of years, and so making sure that you feel like you have battle-tested, opinions and thoughts around how you should really approach AKS. And then today, really, we're taking it to the next level from a security and compliance perspective. So now that we have a cluster up and running, how do we really make sure that it meets all of the requirements or the governance standards that maybe we have set from an internal team? And then last but not least, next week, we'll be doing a session on extending workload capabilities. So if you're watching this before the 28th, feel free to join that session live. And if not, we would love to have you, check out the video, which will be linked in the same channel and in the same
Git repo that we will put
into. Git repo, but I was thinking of like a playlist. Like it'll be in the same playlist as this video. Yeah, I couldn't think of the word, but thanks, Ray, for that. So if you weren't able to join last time, or just for a quick refresher, basically when we talked through what is our baseline cluster, we really focused on 4 pillars. And within that focus, we talked about compute and infrastructure. We talked about process, networking, and observability. And then the actual features or the processes that we would want to have in place on day one. And so we talked about using managed identity. We talked about enabling the uptime SLA. And then we also talked about segregating your workload between both system and user node pools and really trying to optimize the compute needs from that perspective. Then within process, we talked a lot about Azure Container Registry and integrating Azure Container Registry in with your cluster and talking through some of the best practices when moving through environments and making sure that as you get closer to production, you have a more streamlined Azure Container Registry instance. And so that a lot of those same ideas apply regardless of where you're hosting your container images, but we did talk through that. We also talked through having an upgrade plan or a good strategy in place for updating and upgrading your cluster and your host OS versions. And so there's obviously plenty of approaches you can take. So talked through maybe some of the ones that we see customers really gravitating toward. And then last but not least, talked about integrating your cluster with Azure Active Directory and role-based access control, and the different options you have from an authentication and authorization perspective with AKS. And then those last two buckets, we're really focused more on Azure CNI, so choosing the advanced networking option. And we talked through why we did that and some of the pros and cons of both KubeNet, the more basic networking approach, and Azure CNI. And then we talked about enabling network policy on day one. Even if you're not going to fully leverage network policy, it's still good to go ahead and enable that on day one, as it has no real impact if you're not actually using it out of the box. And we talked about quick wins with integrating your cluster, getting metrics, monitoring, alerting, things like that from Azure Container Monitoring Solutions, and log analytics integration as well. So having that log analytics workspace integrated in with that cluster on day one. So based on that, there may be questions around that setup. How secure is this setup? Are we okay having the control plane exposed through a public IP address? Is there a way for us to lock this down a bit more, especially if we have really strict security requirements internally? And then, how do we meet some of these other regulation or compliance requirements that we might have from our internal teams? And so that's what we're really going to talk about today. But before we talk about some of the features that we're going to light up, we're going to talk a little bit about just general security considerations that you should have as you step into this containerized, orchestrated environment. So I'm going to go ahead and take my camera off and focus on the content. So hopefully you have a good view of the content at this point. So what are some of these security considerations when we move toward, containers and orchestrating that at scale? One of them is really around CI/CD, and frankly, this does apply to non-containerized environments as well. But there are new considerations when we do start running our applications inside of containers. And so part of that is things like the container image build itself. So when we have that initial Docker file and are building out our container image, how do we make sure that that base OS that we're basing our container image off of is secure, that it has the least area or attack surface, and we make sure that we have vulnerability detection to understand if and when layers within our image could potentially be exploited. And then on top of that, we have to think about things like CIS compliance and other regulatory requirements that we might have, and secrets management. So within our CI/CD pipeline, making sure that there is a secure access channel to wherever we're hosting our secrets, whether that's access to our Azure subscription or application level secrets. Then we take it up to the cluster level and we think about things like pod, node, network security, right? Making sure that the pod itself is secure, but then also that the compute on which that pod is running is secure. We think about things like identity and role-based access control, which we talked a lot through last time, and then cluster compliance itself, especially if we're in different regulated industries. And then last but not least, really thinking through audit logging from a Kubernetes perspective. So how do we make sure that we have visibility into what the different developers or operators are doing within our cluster, so that we can always tie back these actions and understand, who was responsible for what within the cluster. And that really applies to at an Azure level, right? Making sure we have Azure audit logs to understand, resource provisioning, the people that are active within a subscription, and the permissions and executions that they're taking within that bucket. And then last but not least, thinking through host security. So things like vulnerability detection within the host OS itself, thinking through things like, once again, compliance, and then host runtime security. So making sure that we're doing some type of security scanning to understand that, things that might be happening at runtime within our particular host. So with all of these considerations in mind, we obviously can't touch on all of them in today's session, but we can talk through some of the different features and pieces of functionality that can help us to mitigate or combat some of these different layers of security that we need to be thinking through. And so we made some modifications to our existing cluster in order to better equip it from a security and compliance perspective. So one of those is going to be Azure Policy integration and Azure Security Center integration. So these really go hand in hand, well-oiled Azure machine there for sure. And then from a secrets management perspective, thinking through the use of things like Azure Active Directory pod identity and the secret source CSI driver. Specifically within the context of this webinar, we'll be talking through the Key Vault integration. From a networking perspective, talking through the public versus private cluster, some of the things you have to keep in mind, like your outbound type, thinking through Azure firewall integration, as those are things that typically large enterprises look to secure their network. And then we'll talk a little bit through service mesh considerations. Do I need a service mesh? What are my options? So Ray will do a great job talking through some of the options from a service mesh perspective, which really bleeds into the observability piece as well. So service mesh is really powerful, not only from a networking perspective and doing that kind of traffic shifting and routing, but also from an observability perspective of what's happening within your cluster and within that cluster network. And then last but not least, after talking through service mesh, we'll talk a little bit about intra-cluster scanning. So finding different tools and techniques for not only looking at things like the runtime of the host, but also the runtime within our container images and the images that are executing and running themselves, making sure that we can get good compliance understanding and a good drift detection if and when there's a change that we need to be aware of from a vulnerability perspective for maybe images that are already running as containers on top of our cluster. So you can find all of today's assets under the same repository as last time. So we'll make sure that we link that below in the video. So as mentioned, I think a lot of this just want to really reemphasize the fact that the way that we think about security in the, the cloud native world has to be different than the way that we look at security in the traditional, on-premises running our own hardware sense. And so some of those manual configurations, things that maybe we only did, every so often, are now things that we have to think about doing more iteratively. We have to think about integrating in a repeatable fashion. And so things like treating our security as source control, right? Finding a way that we can repeatably put security processes in place and execute those, through the CI/CD process or, have them running intra-cluster. These are things that we have to consider. And then also, I think one of the fundamental truths is just making policy a fundamental tactic for securing the cluster and your Azure subscription all up. So really setting a strong foundation for what we allow to run within that particular subscription or resource group. Because if we set policy at the enterprise level or set these controls at a higher level of abstraction, then as we get deeper and deeper into, deploying resources and configuring them, we're already going to have a really good foundation from a security perspective. So we really just can't, we can't adopt what we were doing before. We have to think about how to really do security in a more cloud native way. And I think that really means making a shift toward more proactive security measures. So let's talk through why we made some of the decisions around this additional cluster configuration and how these things actually work in order to give us that level of governance that we're looking for. So the security controls in Azure really start with and are built on top of the Azure Resource Manager API. So this is what we use to provision our resources. When we think about things like ARM templates, we're really taking control of that and talking to that underlying Azure Resource Manager API in order to control not only organizational things like management groups and our subscriptions and things like that, but obviously the resources that we're provisioning within each of these buckets. So if you look at this diagram, you can see there's a service kind of right there in the middle, referred to as Azure Policy. And Azure Policy really helps enforce policy regardless of where the origin of that policy is. And this is important because as an organization, we really don't want to be defining policy and defining these controls in a variety of places. We'd like to have a one-stop shop to be able to put these security and governance controls across our resources, across our organization from a consistency perspective. And so we should be looking at the cloud provider to see what they provide from a policy enforcement perspective. And so within Azure, this means really taking advantage of Azure Policy. And so Azure Policy is really going to be the fundamental policy engine that we look at today to think about how we secure our subscription, as mentioned, at that higher level, but then also apply that at the resource provisioning stage and also intra-cluster. And so that's what Azure Policy for AKS really provides us. And so we'll make sure that there's very clear understanding of what we get with each of these different implementations and features. And then, the Azure Resource Graph really gives us the ability to query and see what's happening within a subscription, see where our resources lie. And so the combination of all these things can be very powerful. Things like Azure Blueprints are really powerful ways to standardize your infra as code across an entire organization and things like policy as code, right? So we have a blueprint that basically has a series of ARM templates that help set up the Azure ecosystem in which we'll then operate on top of. And if we can follow things like Azure blueprints, creating policy that applies across the subscription, creating the appropriate RBAC rules, which we emphasized last session, then we're at a really good place to then look at the cluster and say, how can we take this to the next step? I will say one thing that's really that I would recommend that kind of falls into this this image that you're looking at here is an idea of capturing the audit logs for your Azure subscription. And so Azure logs are captured through what's called Azure Activity Logs. They capture all of the Azure Resource Manager interactions, so all of the interactions with that API. They only have a certain retention lifecycle, so you do have to kind of think about things like exporting the data from activity logs into something more persistent, like a log analytics workspace or even maybe a blob storage. But the goal here is really finding out how you can have full visibility over what people are doing within your Azure subscription or your Azure tenant. And once we have visibility into that, then we can take things to the next level. So if you're not familiar and haven't used Azure Policy before, really the goal is a governance platform to enable large enterprises to govern their Azure cloud environment at scale. And so this helps things like standards and guardrails when it comes to compliance and regulation, things like auditing, right? So typically large organizations have these security groups that want to do audits of their environment. And so to be able to have that data is really critical. Being able to have things like drift protection, right? I want to know if the subscription I've set up or the resource group, whatever the scope is at which I choose to apply my policy, is still in compliance with what the protocol or the the rules that our organization has put on us. And so if we don't have an idea of what that is and we don't have that applied, then how are we going to know if something is no longer in compliance? So this really is a consistent management plane for policy all up within Azure, and you get to choose the scale and the scope at which you apply this policy. And then on top of that, you can actually add policies to resources, whether that is, I guess, remediating, so actually fixing things when they come out of compliance, or just having awareness of when they don't meet a specific standard. So that's really the goal for Azure Policy. And so when we talk about what is Azure Policy for Kubernetes, we have to then think about how we take this similar model and apply it at the intra-cluster Kubernetes level. So let's take this to the next level, right? So we have our, hopefully it was maybe an Azure blueprint that we deployed. It has all of our RBAC rules. It has policy. We're able to deploy that through a CI/CD pipeline, really shifting security left and making sure that we have all of that set up for that good kind of landing zone, which we do have great content around this from a landing zones perspective. And so I would love to share that as well below in the video resources. But when we take this to the next level, right, and we think, okay, now we have Azure Policy applied, and Azure Policy can let us do things like, hey, I don't want to be able to have developers within resource group A deploy to any region other than East US and West US. So I can set Azure Policy at the resource group level that restricts the locations that my Kubernetes cluster can be deployed to. But what happens when I want to say, I want to apply intra-cluster policy? I want to say that specific developer cannot run pods within the default namespace, or we cannot use images from an untrusted registry and run them within the cluster. Well, that's where Azure Policy for Kubernetes really comes into play. So we're extending that Azure Policy engine and that ARM into the Kubernetes cluster itself. So this is very similar to kind of the same process we took with things like Azure Active Directory, right? We take the traditional identity approach that works at the resource group level, at the resource level, and then we extend that intra-cluster. Same with RBAC in Azure, right? Taking that and extending it to the cluster. And so what you'll get here is that full end-to-end experience where you can use what you're used to using in Azure for security and governance, and then really extending that and pushing that down in the stack to the cluster. So Azure Policy for Kubernetes is actually built on top of an open source project called Gatekeeper v3, which is an admission controller webhook for the Open Policy Agent, which is also an open source project. And so OPA as a project, or the Open Policy Agent, is a policy engine for cloud native environments. And it was basically created by, or at least it's hosted by, the Cloud Native Computing Foundation. And the Gatekeeper project is essentially an implementation of OPA that is specific to Kubernetes and mission control. So you could technically use, the Open Policy agent for securing and doing policy in other cloud native environments, but we're thinking specifically about Gatekeeper, the implementation that's focused on Kubernetes. So Gatekeeper, what it is, it's basically a policy library, and through the use of custom resource definitions, which we've mentioned in the past couple of, or at least in the last webinar, and most likely you're somewhat familiar with it if you've run in Kubernetes, but a resource definition that basically one of them is called a constraint, and then one of them is a constraint template. And so the goal of these resource definitions is that we can create policy on the cluster and then apply those constraints, as needed on our resource. So as of right now, the Azure Policy for Kubernetes is a managed version of basically what you could get out of the box if you just deployed Gatekeeper yourself to your cluster. So it's very similar to things like AAD pod identity, right? I could technically go out to the open source project, apply it on my cluster myself, or I could use, the managed add-on that Azure provides. And so we're going to talk specifically about the Azure Policy for Kubernetes add-on. So we're not having to actually go deploy this open source project ourselves on the cluster. Instead, we're using the quote unquote managed, version that Microsoft has built on top of. And so as of right now, Azure Policy for Kubernetes only works on Linux nodes, and you can only use built-in policy. So what does built-in policy mean? Well, it means there's going to be a set within the Azure portal of policies that Microsoft provides to you that you can apply within the cluster. So this is going to be things like, cannot run pods within the default namespace, cannot use an image from an untrusted registry, so on and so forth, cannot run a pod with privilege escalation. So it'll be things like this, right? But I can't necessarily go and take my own constraint template that I built using the open source Gatekeeper and apply it within the AKS add-on. So this is definitely what I would say is the biggest constraint of the current offering, but that is something that will actively be added in. I don't know if that's currently in development. I can't speak too much to that, but we'll definitely put that in the Q&A. But this is something that we expect long-term to be supported. So just kind of a waiting game until, bring your own policy within the Azure Policy for Kubernetes. Kubernetes is enabled. So when you are thinking through Azure Policy for Kubernetes, it should be scheduled on a system node pool. So based on the way that we talked before, right, system node pool versus user node pool system, really for those critical add-ons, it would make sense that the Azure Policy for Kubernetes bits would run on the system node pool. And then essentially the way that it works is that the add-on checks Azure Policy, obviously Azure Policy, the engine that's running in our Azure, tenant, for changes every 15 minutes that we've made within Azure Policy, right? So maybe I apply a new policy or I deactivate a particular policy. So we're basically going to have reconciliation between the Azure Policy add-on that's running in the Kubernetes cluster and then the Azure Policy, I would say maybe kind of control plane that's running in the cloud. And then if the cluster subscription is registered with Azure Security Center, this is just kind of a little gotcha. So if you've already if your subscription and if the cluster in which your if the subscription in which your cluster is running in is already registered with Azure Security Center, then these Kubernetes policies will be applied on the cluster automatically. So keep that in mind. So why is this important? One, we can shift left, right? So if a developer automatically gets denied a certain action when they're working on our cluster, we don't have to go through the process of CI/CD in order for the developer to then get an error that says, hey, no, you can't do, you can't run in the default namespace. We'd much rather have the developer know that right at the entry point so that they can make remediations themselves. And so we really want to make sure that our developers understand security best practices and are seeing those in action as close to their development cycle as possible. If you've heard of the pod security policy functionality within Kubernetes, it's being deprecated upstream. And so therefore it's also, that's propagating into AKS. So it's also going to be deprecated. So right now the pod security policy is in preview, but that will never go GA and will eventually be deprecated. So Azure Policy for Kubernetes is a really great alternative to be able to implement some of the same features or some of the same compliance restrictions that you would use pod security policy for. Another is that consistent governance experience. So we talked about how on Azure, Azure Policy is obviously used at the subscription level, resource group level, resource level. So to be able to bring that into the cluster and use the same mechanisms and methodology that we're used to is a huge win. And then as custom policies are supported, we have the extensibility to then bring our own policy. So really the goal of this is to make sure that we're applying that at scale enforcement and safeguard on the cluster in a centralized way. And it makes it easy to report on the compliance state of the cluster as well. So I want you to keep in mind too, if we're thinking about things like hybrid deployments with Azure Arc, for example, Azure Policy is one of those things that we can push down to that cluster. And so if we have the, if we have our policies set in place, using Azure Policy, we can then use the same policy engine across Kubernetes clusters, be it on premises or in another cloud provider. So the more consistency we can get, the less operational overhead. So I just want you to keep that in mind. Definitely recommend Azure Policy and enabling that on your cluster from a compliance perspective. It's certainly a great tool for that. So I thought this was a good slide to just kind of put some of this in perspective in terms of like how this actually works. So if you think about it, as we mentioned before, the Gatekeeper project is works with the Kubernetes admission controller. And so when we think about admission control in Kubernetes, we think about decoupling these policies from the API server itself through these webhooks. And so as a resource is created, which you can see here in this slide, the HTTP or the API request coming in. So once we say, hey, we want to create, for example, a pod on our cluster. So when we tell the API server we want to do this, we can then basically use things like mutating webhooks and validating webhooks in order to determine, if that particular resource is in compliance or should run on that cluster. And so Gatekeeper really falls and Azure Policy fall in the mutating admission. So the mutating webhook basically validating, not mutating. So eventually mutating, that's something that's in the works, but it's really on the validating side. So it's not going to make any changes like, for example, injecting a sidecar. So a mutating admission webhook might be something that says, hey, I want to make sure that every pod annotated with, Istio equals true gets an Istio sidecar injected from a service mesh perspective. So it's actually making a change to that particular resource on the cluster, whereas a validating webhook basically just validates these requests. You can obviously run them in parallel because they're not making any changes. And so an example use case for this would be restricting the creation of a particular resource. And so this is how that Azure Policy is really working. That add-on is basically intercepting there in order to apply that policy and make sure that your resource that you're trying to execute on the cluster is in compliance. And so policy enforcement in general, across Kubernetes and across Azure Kubernetes Service, like admission control is really about policy based on those intra-cluster objects, whereas the network policy, like we mentioned last time with Calico, is focused more on the data plane. And then RBAC is policy that's obviously enforced on the user. So we really have layers of policy that we have to consider in order to secure that cluster. So what does this look like? Pretty simple. I think this just puts it into perspective. So basically, let's say your cloud architect chooses from a set of predefined policies for your AKS cluster, and then basically applies this through Azure Policy, and then you have a developer that's interacting with that cluster using the Kubernetes API. So then maybe the developer says, hey, I want to run a kubectl, apply and pass in this YAML file that's going to spin up a couple pods in a service. So let's say they do this on cluster 3. They can basically get a response back from that validating webhook, which the add-on is clearly taking that place and bringing that functionality to the table to understand that, hey, you know what, this actually is not something that you can do. You can't use a default namespace. Your deployment was unsuccessful. And then at the same time, the cloud architect can have a visual audit of which clusters are in compliance, what is out of compliance, even drilling down to the namespace level of granularity to understand where is the pod running, what is the pod called, is it a service, is it a config map? And so you get a lot of really good observability from the cloud architect's perspective, and then the developer gets immediate validation of if something can or cannot happen on the cluster. And this obviously can be applied through CI/CD as well. And so don't have to just do this, at the single level, right? You can set Azure Policy, apply that at scale, and then as a developer is going through and maybe checking in some code from a GitOps perspective or through, a GitHub action, basically they can have compliance that's baked into that Azure pipeline to basically say, hey, no, we're not going to go through and apply this change because it's not in compliance with what the cloud architect, has set up. And then that cloud architect can actually get a notification or, visualize that via compliance dashboard. So one of the key benefits to leveraging this entire, governance and control auditing, all of this is, we get that out of the box visibility into what's happening from a compliance perspective. And so for Azure, in addition to just using Azure Policy, part of this includes things like Azure Security Center. And so Azure Security Center can really be that single pane of glass for compliance and governance observability, big words. So what does this look like from a Security Center perspective? Well, once again, before we create anything out of the box ourselves, we need to look to the cloud provider like Azure to determine, what are the best practices from a security monitoring perspective. And so within Azure, we can use things like Azure Security Center to get recommendations around best practices and ways that we can basically secure our subscription, our resource group, our resources to be as compliant and secure as possible. And so, for example, like when we fire up Azure Security Center and we wire it up with our subscription, for example, we can determine whether or not our AKS cluster has things like IP whitelisting enabled. And so maybe we don't, maybe that's not required for us. While it may be recommended, you don't necessarily have to implement, every single suggestion. The goal is, hey, how can we get an understanding of where we sit from a compliance perspective and things that we could do to take our security and governance to the next level? And so basically, as a new subscription is provisioned, as a subscription is wired up in ASE, as a new cluster is created, each of those clusters is going to be discovered through Security Center. And so Security Center will take a look at that. And as I mentioned, if your cluster sits in a resource group or a subscription that's already governed or connected to Azure Security Center, you'll get some of these insights for AKS right out of the box. And so it'll provide some really good recommendations, like I mentioned, things like IP whitelisting, or maybe we're not using a managed identity, so it can give us some recommendations for things we can do to remediate that. And then as things occur, Azure Security Center can continue being a single pane of glass for us to come back to and monitor our AKS cluster. Now, I will say one of the challenges here, so it's great that we get some of that workload configuration through Azure Policy visible to us in Security Center. So we can surface up the Azure Policy compliance through that Azure Security Center dashboard. However, let's think about things like the runtime scanning, which we mentioned before. So there is a concept called Azure Defender, and basically that provides both host level and cluster level security scanning, but only if you're not using virtual machine scale sets in AKS. Now, when would you not use virtual machine scale sets in AKS? Very rarely, because, for example, if you're using node pools, that's going to be backed by virtual machine scale sets. So in this case, you have to have kind of some third-party tooling to get that runtime visibility and threat detection. So while Azure Security Center can definitely provide us some good insight, it's definitely that from a compliance perspective, that single pane of glass, it's not going to be able to provide us those, host level metrics that we might really want to see. And so that's where it really comes into play, thinking through, hey, how do we then, onboard potentially a third-party tool to be able to get some deeper understanding of what's happening intra-cluster from a scanning perspective. And then I do want to call out here, ACR is also supported within Azure Security Center. So basically, to monitor images in, ARM managed Azure Container Registry. So really, Azure Container Registry is the most, natural marriage here. But you can basically enable Azure Defender for your container registries. And so Security Center will scan any images that are pulled within the last 30 days or pushed to the registry or imported, as you can see here. And then basically that integrated scanner is provided by Qualys. And so you'll get some information regarding, hey, there's a known vulnerability here, or there's an outdated library that's being used in one of your base images. And so you'll get notified via your Azure Defender dashboard, which can also be accessed, through Azure Security Center, all very integrated. And then you'll have recommendations along with what you can actually do to remediate. So along with these, you'll get like, hey, is it severe? Is it, is it a warning? Is it kind of a, big flashing red stop sign that you need to do something about this? So there's obviously levels of severity from a classification perspective. And then you can also filter based on what you'd like to scan for. Now, keep in mind, though, this doesn't do intra-cluster scanning. So it's a good baseline, but it's not necessarily going to be sufficient to continuously monitor because, for example, you could have in a container that at the time it got deployed to your cluster was totally secure, and then something comes out down the line, and you'd want to be aware of that, the fact that A, it's running on your cluster, and B, that you'd want to have some kind of agent running in the cluster to kind of give you insight into this. And so once again, Azure Security Center should be definitely enabled, but it does have some gaps that other technology will need to fill. Okay, awesome. So let's switch over a little bit to the process focus for pod identity and the secret source CSI driver. So let's do a quick identity overview just to remember some of what we covered last time and just in general, the different layers of Azure AD integration that we can have within a cluster. So one of them is, let's imagine that we have Active Directory enabled our cluster, meaning that whoever is going to interact with the cluster needs to be able to authenticate to it, right? They either need to be part of an admin group or they need to have a role within Azure that allows them to access the cluster and take particular action on that cluster. So that's what Azure AD enablement gives us, that multi-factor authentication to get into our cluster. Then we have to set up some kind of Kubernetes RBAC in order to determine the roles that that person has within the cluster, right? So more the authorization perspective. And in this case, right, we could use the Kubernetes RBAC through roles and role bindings, or cluster roles and cluster role bindings, or we can use the new preview feature, which is the Azure RBAC K8's authorization. So that's really going to be taking and extending role-based access control within Azure to the cluster level. And then once we've done that, we obviously have to think about our application running. So our goal would be, hey, we're doing some kind of secret management within our container or within our pod to make sure that our application has secure access to the credentials it needs in order to reach out to other Azure resources, be it a database, some kind of storage, maybe it's service bus, whatever that pod might need access to. And then from there, there's this concept of pod identity. So this is what we're really going to get into today. And that's how do we actually take the concept of Azure Active Directory identity and push it down all the way to the pod level, where a pod can have its own Azure identity and have specific access to resources through that Azure identity. And so typically the scenarios where we see a need for this are going to be things like developers need to assign identity to their services, to access resources, one of those being Key Vault, as mentioned, right? If our secrets are in Key Vault, we have to find a way to then authenticate to the Key Vault to give our container or application code access to that. But then also needed by developers for security across Kubernetes clusters so that pods can authenticate and access APIs exposed by other pods. And so this is something that is down the line, but it's a consideration. So just a quick overview of what pod identity is, right? It allows us to give an identity within Azure Active Directory so that our particular pod can then access a cloud resource through Azure Active Directory. And so we make use of the same, very similar paradigms as we did when we were thinking through, Azure Active Directory with RBAC. So we have identities and bindings to make sure that we have, an Azure identity that's been created. And then we have a binding that actually takes that identity and gives it down to one of our Kubernetes pods. And then the goal would be that without much modification, our containerized apps can then leverage any resource that also uses the same, Azure Active Directory identity provider. And so this is what that flow looks like. So I will say the flow is going to differ if you use the open source Azure Active Directory implementation or the Azure Active Directory add-on. And so we're really within this slide talking about the AAD pod identity add-on. And so what is that? We created something that's out of the box managed, very similar to Azure Policy, where you can enable providing pod identities to your pods within your cluster. So the way that this works is imagine you have like a cluster operator who basically is going to map identities when pods request access to particular services. So we do this through some custom resource definitions. So Azure identity binding is what's going to take an Azure identity and bind it to a pod. And so that's all going to use the familiar kind of paradigms of like labels, selectors within YAML to make sure that we wire up the pod with the corresponding Azure identity. And then basically the node managed identity server is going to take the pod requests that come in and work with the Azure resource provider to get access tokens through Azure Active Directory. And then whenever a developer says, hey, I have a pod, that pod is going to use a particular managed identity, it'll access that token through the NMI server. And then basically the NMI server will then return that token to the pod so that the pod can securely access resources. So keep in mind, this kind of cuts out the concept of the managed identity controller, which you'll see if you set up the project yourself. And the NMI pod is basically a daemon set that's running on each node within the cluster and listens to those requests for the pod to reach out to an Azure service. And so instead of manually giving these credentials to pods, these managed identities can access resources by requesting those tokens in a real-time type of way. And so I will call out here, there is some nuance around this topic, and we got good feedback on the last session. So Azure Active Directory pod identity is, as an add-on, is in preview. That will never come out of preview. Essentially, what we've kind of taken feedback in as a team, and I think the engineering team has considered the fact that there are ways to further streamline and take advantage of some of the new features in Kubernetes to make the pod identity experience much more secure and battle tested. And so they're basically rewriting that, and that's public information. You can see it on the GitHub repo. So they're going to create a pod identity v2, and that's really going to be the strategy moving forward. So while pod identity is definitely a really great step in the right direction and should be taken advantage of, I understand that it is in preview, so you want to take that into consideration when thinking through production workloads. But there is still the opportunity for you to use things like the AAD pod identity open source project, at your own risk. And that's really the reality of most open source projects. But continue waiting on this space because it certainly will continue to be clarified as we get closer to that V2 release. So once we think about, okay, in an ideal world, especially as that V2 version comes out and it's fully managed and supported by Microsoft, the preview will continue to be supported with limited scope. So if you take a look at the docs, you'll see kind of the support we provide for preview features. But obviously, as that V2 feature goes into GA, that will have full support from Microsoft. So that's really the long-term strategy and goal moving forward. But even if we weren't using pod identity, we still have to think about, okay, whether I use pod identity or use managed identity or use a service principal, at some point, even if my pod has access to my key vault and has done that authentication, how do I then access the secrets? How do I make use of them once I actually authenticate to the key vault itself? And so we recommend using something like an Azure Key Vault, obviously, to store those secrets. We recommend using something like pod identity to then be able to authenticate a pod to get access to your key vault. But then you really want to make sense of those secrets. You want to put them into your code. You want to inject them. And so, one of the biggest things to think about is creating and defining credentials in application code is never a good idea. Instead, using something like managed identity or pod identity will allow you to store those in an offloaded way. So that's kind of really step one. But then to limit the risk of credentials being exposed, things like that, I also would say, I recommend against using things like Kubernetes secrets. Now, there's times in which that can be appropriate or scenarios in which that might be sufficient. But the reality is that storing these like base 64 encoded values as Kubernetes secrets are really not the most secure approach. And so while it may be the easiest, because we can then just inject them directly into environment variables, we typically want to offload those to something like a key vault. And then we have to find a way that we can then take those and access them from the file system or do that environment variable injection from the Azure Key Vault itself. And so that's where the secret source CSI driver comes into play. So let's say we've chosen to use pod identity. We've chosen to use Azure Key Vault to secure our secrets. Let's say we have this pod. The pod is running in our cluster, and the pod needs access to a SQL database. So if we were to just use something like a Kubernetes secret, we do the base 64 encoding. It's stored, etcd keeps track of basically all of the configuration within the cluster. The pod reaches out, gets access to the secret, and then can access the SQL database. But obviously, if for whatever reason our cluster is compromised, someone can get access to etcd, or someone gets access to that Kubernetes secret. They can then have access to our Azure resource, which most likely we don't want them to do, right? We want that to be as secure as possible. So instead, we'll use something like an Azure Key Vault. We will store our secrets, our connection strings in the Azure Key Vault. You can do, things like certificates as well. We can reach out from the pod to the Azure Key Vault using, obviously pod identity would make great sense. You don't have to use a pod identity. You could use managed identity. You could use a service principal with secret. So there are several approaches you can use. But the goal is we then get that secret that's mounted to the pod. The pod can then make use of that secret to access the SQL database. So some of the features from a CSI perspective, it does basically mounting of secrets, keys, certificates on the pod using the CSI volume, the container storage interface. And so you can mount multiple secrets within as a single volume. You can use pod identity to restrict access. You can support Windows containers. It syncs with Kubernetes secrets if you want it to. So you can basically say, hey, I want to sync all of these secrets in Azure Key Vault with secrets in Kubernetes. Once again, still not my personal recommendation, but it is possible. And then also you do get that auto rotation of secrets, which is certainly a major benefit. And so the goal here is really to mount those secrets as alongside your pod to be able to access, other resources from your application code. And so this is just a kind of a good marriage there. So I'll kind of talk a little bit about recommendations, right? So ideal is use pod identity with the Azure Key Vault provider for the secret source CSI driver. Keep an eye out for those pod identity updates, and keep in mind Azure Key Vault the Azure Key Vault provider for the secret source CSI driver, this project is open source. So once again, there's no Microsoft support necessarily, but keep in mind, right, we're moving toward an open source space where there's a lot of governance and control around these open source projects. Kubernetes itself is an open source project. So while we do provide, that layer of support when you bring it into AKS, just because it's open source doesn't mean that it's not going through a process from a governance perspective to make sure that it's tested. It's just a bit different from that support perspective. And then also, we're going to talk a little bit about Dapper in the next session, but just keep in mind, you could actually think about using Dapper for abstracting secrets if other features of Dapper are compelling to you. And so we'll talk through that next time and what that really looks like and how that might help optimize some of this process that otherwise would be a bit more challenging. So now I'm going to pass it over to Ray. Ray's going to talk through private clusters, a bit of that networking, talked a little bit about service mesh. But Ray, before we jump into this section, is there anything you wanted to add, just kind of based on some of what I talked about with identity or governance from an Azure perspective?
Not too much. I think the message you had in terms of moving secrets out of Kubernetes itself, the base 64 encoding part of it, to me it's not secure. It's not a secret. It's just obscuring the actual value in there. So I think that messaging in terms of using a Key Vault, whatever you decide to use, right? I mean, clearly we prefer Azure Key Vault, but as long as you're using some kind of Key Vault system instead. So like if you want to roll your own, HashiCorp Vault is a good solution. There's also a bunch of other providers out there. So that one to me is like a major one that is sort of in everyone's, like the elephant in the room when it comes to secrets in Kubernetes.
Yeah, no, good point. I'm glad you called that out. Okay, awesome. I'll pass it over to you.
Okay, thanks. All right, here's the handoff. Okay, I believe that's presenting as expected. And I'm actually going to turn my camera on because I talk with my hands when it comes to the networking pieces. So I think that is working as planned. Okay.
I will say I agree, Ray. I'm like over here, like moving my hands all around talking. And I'm like, sometimes it probably makes more sense to just keep the camera on.
Yeah. But for me, especially the network flow when you're talking about like I'm doing this, and kind of makes more sense if you can map like my animated gestures, I think. But yeah. Okay. There we go. It's working. All right. So we're going to talk about private clusters, and I say private clusters with quotation marks because when we talk about AKS private clusters, at least literature, the docs refer to private clusters as just the control plane portion of it. So the Kubernetes control plane, where you actually make kubectl command line calls to, the Kubernetes API server, it's also known as, that's the AKS private cluster. We're going to fully talk about a private cluster. So one of our peers over in Europe, Dennis Zilke, he's got a great Medium post that talks about, AKS and being like fully private clusters and what that entails in written form. But the idea is that we've got, yes, the control plane is private cluster or private endpoint, that is to say, so it's only accessible in Azure private networking. But you also need other components that most corporations consider a private cluster. No public IP addresses, forcing the traffic of your actual worker nodes through some kind of appliance like a firewall and things like that. So we'll cover that. So this is a bird's eye view of all that, more or less in a nutshell. There might be missing one thing, especially around DNS around that. We'll get to in a little bit. But generally speaking, this is what we're going to cover in the next little bit. So the first part, again, another eyesore diagram. I made this, I'm not a PowerPoint expert, but this kind of encompasses the idea of what the private cluster, that control plane, is doing for you. So on the far right-hand side of the diagram itself, we've got the actual AKS or Kubernetes control plane. So your API server, etcd, the scheduler, the controller, all that is on the right-hand side. So that lives inside a Microsoft or an Azure managed subscription. Master node, if it's 1, 10, 100, whatever it might be, we take care of that for you, just like in a non-private cluster scenario. The biggest difference being is that the communication to that endpoint doesn't go over the public internet. It stays within Azure itself. And more importantly, when you address or resolve that control plane, it actually is given a private IP address within your subnet that AKS is deployed into, as well as a private DNS zone name. So DNS name. So in this particular case, it's going to be given a DNS zone name within a given region in the templates that we provided for you in the GitHub repo. I think the default, if I remember correctly, is in East US 2. You can modify that accordingly. But then that cluster name is only resolvable as in a private endpoint inside Azure networking, right? So it'll resolve to this IP address, and then any of your kubectl calls or even the kubelets themselves, or if you got a Jumpbox or Bastion server or some kind of a min VM inside your network, will resolve accordingly to that endpoint across private networking. This also means that you can't access that private cluster or that control plane from home. So if you, like me, in a basement of your house and your ISP at home, I can't run arbitrary kubectl commands to that control plane over public. I have to peer myself somehow into my Azure virtual network, right? Whether that's with VPN, maybe I've got a corporate connection, like a VPN to my corporate on-premises VPN server, which that is peered via ExpressRoute or some other mechanism to my Azure VNet, some way around that. But basically, I have to be part of the same private network. So in that case, what happens is that I need to be able to resolve that control plane API endpoint via my private networking. I have to have some kind of DNS server and all that. And this is the complicated part above and beyond just this private network, private cluster part of it all. We have to make sure we can resolve that name, right? If I can't resolve the name, I can't actually send or resolve any of my commands to that control plane. So this is a larger topic. It's kind of in preview right now. We'll call it like bring your own DNS to AKS. Our peer on our actual direct team, Steve Griffith of New York, has got a good write-up, and he's actually been on our little plug for our public office hours, which Kendall also runs. A session, I think like 4 weeks ago at this point, around bring your own DNS. So if you're, your organization has your own on-premises, whether it's an Azure Active Directory domain controller or Bind9 DNS server or other flavors in between, if you've got that on-prem and you need to figure out how do you configure routing back to that on-prem, maybe you have it sitting in an Azure, how can you actually bring that and tell AKS that this is in fact the name server that resolved this address on our behalf? Right. There are additional links to that as well. And that's something that I would probably say get into contact with a networking expert to talk a little bit more in detail about how to set that up. This is an optional thing, so we're not going to cover it today. And it's not really around security. It's more about getting this private cluster set up. All right. So having said that, the other half or pieces are 2/3 of private networking. The first part is how do we actually lock down and control the traffic coming into our cluster, right? So by default, for Kubernetes cluster itself, when we talk about the traffic coming in, I mean traffic coming into actual application workload, your your load balancer that gets assigned to your cluster gets a public IP address. In some cases, you can use this as the actual public IP address. You can attach like an A name record for a public DNS record that you have, or a C name, whatever, to the cluster itself. But in most organizations' cases, you want to make sure that your load balancer has no public IP address directly attached to it, because the preference is to instead put a firewall in front of your cluster, in front of that load balancer that serves up Kubernetes. So in this case, you'd prefer instead that there's a public IP address that you can have a little bit more control over, attached to some kind of appliance. In this case, it's an Azure firewall, or it could be an F5, it could be a Barracuda. You name your appliance of choice, but that sort of fronts your cluster publicly. And therefore, you can set up rules accordingly, right? It's not a shotgun approach where all requests to that IP address will go directly to Kubernetes. We'll have to set up destination NAT rules, right? So it can be based on any of the tuple, right? Like host name, IP address, port, protocol, etc. The firewall will then be the authoritative source to say, okay, I recognize this traffic. I've got all the addressing information I need from the tuple on the rule, and want to forward it to the internal load balancer, so a private load balancer inside my network. That private IP address is what represents your cluster. So it'll know to send requests to in a round robin fashion, or you can change the algorithm accordingly to the actual worker nodes, so the non-control plane nodes of your Kubernetes cluster. Okay, so the node pools, they could be a D2, they could be some kind of GPU node, but the load balancer will shuffle that accordingly. Now that will then hit your ingress controller, and you can do things like SSL termination at your ingress controller. You can do SSL pass-through directly to the pod itself, up to you in that sense. But this first part is how the ingress actually makes its way through. So we've restricted it down. There's no public IP address on the load balancer, so you can't circumvent a firewall, because with load balancers, you can't really set any rules around it. So all the rules are on firewall itself, goes to the private load balancer, and then forwards traffic accordingly to your ingress controller, and you can handle layer 7 routing accordingly. Right? So that's the sort of the second third of this private cluster scenario. The third part, the last part of private cluster would be the egress path, the outbound traffic of our cluster. So when traffic originates from the Kubernetes cluster itself, one of your worker nodes, maybe that's what your app is trying to do. It's trying to reach out to, say, a third-party API of some sort. An example, like there's a Star Wars API out there, and you can look up, planets and other spaceships or spacecraft and characters like that. That doesn't reside inside our network. We don't actually serve a private API input for that. We need to reach out. Do we allow this at all, right? Is this something that we actually want access to? So again, using the same firewall, and perhaps it's a different route for egressing out of our cluster, we can set up a path that we have full control over and say any traffic that isn't inside our network that we don't have internally, we will force it through the firewall. Typically, this is referred to as the default route. So 000/0 if you're used to CIDR notation for networking. And what we'll apply is a user-defined route on that particular subnet. So it's signified by that homunculus human character with an arrow beside their head that says, okay, any routes that match anything, or that does not match anything that we do know about, will be forced to the private IP address of the firewall, and then from there, let the firewall figure out if it can or cannot escape your cluster, right, or escape your network. And so this is the last part of a true private network, is controlling it through firewall rules outbound. Do keep in mind in the templates that we are deploying in our webinar examples that we've set up some rules for you. This may not be all encompassing for your test cases. This only kind of generically covers what most customers would need, especially from the perspective of Azure endpoints that are needed. Management.azure.com, which is the actual Azure ARM control plane that checks on the health of your actual resources. Are your VMs up? Are they healthy? Should we shut them down, restart them? That's semi-separate from the actual Kubernetes control plane around that. Other things like Azure Monitor and We've also added in there Docker Hub. So if you want to deploy a test container just to check the environment, you have to whitelist those rules inside the firewall, and it's included in there. So that'll give you a sense in terms of what you need to get started. There are organizations, when we talk about from the last session about container registries and how do we actually set that up, you actually might want to remove Docker Hub altogether from your firewall rules, meaning you're blocking it, and only allow traffic to your private container registries. In our case, from a webinar perspective, it would be the Azure Container Registry that is being deployed in the demo itself. And then this way, you're guaranteed that only the container images which you've sort of blessed and said or approved live inside that registry, and you can only get access to that registry accordingly, and don't reach out to some unknown, unsigned public image that's on Docker Hub. Not to say you can't trust them, but for compliance reasons, you probably should restrict that down a bit more. Okay. Moving along in terms of networking and observability from a service mesh perspective, this is one of my personal favorite topics. First of all, it's it's still a burgeoning area in my opinion around service meshes, whether to use them, whether not to use them. So, I mean, the ultimate question is, do you actually need a service mesh? And this really boils down to, do you need sort of the 4 main points? Every service mesh actually has a little bit more than just 4 features, but the majority of them will have these 4, and whether or not you need them in your organization, and what is it you're actually trying to achieve with the mesh itself. So first of all, what is a service mesh? So a service mesh itself is part and parcel with like service discovery. So like DNS is kind of baked into it. I can identify certain instances of my application as being a particular microservice. I can find out where they are based on their name. I don't necessarily need an IP address. Same idea as a DNS kind of lookup. And it also provides you a way to securely communicate and shape the traffic going to those given services. So on that, the 4 main sort of features of a service mesh that you would expect, MTLS, mutual TLS encryption, which also provides identity of the service itself. So we can ensure that SSL or TLS is happening between my actual services inside the cluster, as well as being able to provide an identity that, I have a microservice, let's call it app A, identifies itself as such, and it's trying to communicate to another microservice, app B, with that TLS certificate. Not only are they representing itself as app A, it also requests that app B, represents itself as app B, so that there's a mutually identifiable way to say, okay, I'm trying to reach out to you. Are you who you actually are? And vice versa. Okay. Based on that too, because it's signed by a centralized authority, your internal private root certificate authority, you're guaranteed to know that these are in fact trusted individuals that you would expect to be contacting with. And then this establishes that TLS connection so that we make sure that anything that we're sending between each other can't just be inspected, like our packets can't just be inspected. So this is one of those, I think, top tier sort of requirements of a service mesh, because going back to the ingress point that we saw on a couple slides ago coming into the cluster, that's kind of easy in terms of encrypting it with SSL or TLS. We can do SSL termination at our ingress controller, and that's great. Traffic coming in from the public internet, going across our private network up until the ingress control, up until basically our subnet, that's guaranteed to be encrypted, right? If we're setting up TLS on our ingress control. That works well. But then the last mile, let's call it, from the ingress controller to actual application workloads, that could be unencrypted traffic, meaning there's no SSL termination or TLS termination between the ingress controller and our actual microservice or pod. So as a result, from a compliance perspective, from a security perspective, if someone did somehow hijack our network, we have other problems altogether. But if they did deploy or were able to inspect packets traveling within our network, they could see things in the clear. This could be passwords. This could be, you name a whole bunch of secrets, as we mentioned before. So if it's unencrypted, you could just capture that and log it accordingly. What we'd probably want to do is, again, set up a service mesh so it's there inside our infrastructure. We don't have to think about it. It's enabled, turned on, and anytime our services talk to each other, or if we have a ingress controller that can join our mesh, we're guaranteed that we have full end-to-end encryption accordingly. The alternative to this is SSL pass-through, but that's only good directly from public traffic into our pod, not necessarily between pods inside of our microservices environment or ecosystem itself, our internal network. Okay, so it's a big one. Have to mention that, and there's a lot to think about in terms of encrypting traffic end to end. The good thing is that, again, most service meshes employ this, so things like Linkerd, Console, Istio, they have MTLS baked into the actual service itself. Nothing you have to think about. It'll set up PKI system or the root certificate authority on your behalf. The other three things, so we'll start in the next one. Second point that you need from a service mesh perspective, a canary or phased rollouts, right? So I've got V1 deployed. I want to deploy V2. How can I slowly drip traffic over to V2? So I start off 100% traffic on V1. I want to eventually get to 100% traffic on V2. How can I slowly drain or change the percentage of traffic from V1 to V2? I may go 80% to V1, 20 to V2, and then eventually roll it over to 100% V2 traffic. So canary phase rollouts will help us determine that. And what we can do, how we can do this, is that service meshes also provide on top of this the idea, sort of third point, connecting the two, is it's able to intercept traffic. It's able to observe what's going on. And based on that observability feature, we can actually see a request per second going as expected. Are we seeing a lot of 500, 400 errors? What's going on? Do we need to roll our version back to V1 because V2 has got some kind of catastrophic failure going on? Or hopefully conversely, V2 looks like it's working exceptionally well. No failures or very minimal or tolerable failures or expected ones. And so we can actually progress the deployment out to 100% to V2 as we had hoped and expected. The third and last point in this, because I kind of skipped and talked about observability first, traffic management. How can we actually define how traffic routes through the system based on protocol, based on ports? And can we actually do things on the policy level to say application A can talk to B, but B can't talk to C, and so on? So that combination thereof. So we did talk about network policy in the past, around setting up between namespaces. That's a great foundational thing. But how can we actually get a little bit more granular to be able to identify applications by their identity and say that they can or cannot talk to a sibling application accordingly, right? Or how can we actually define how this traffic routes based on that similar identity? So questions to ask when you're doing this, right? Is the ingress controller sufficient? So that, again, going back to that encrypted traffic or trusted traffic end-to-end, is SSL termination at the ingress controller and then assuming all the other traffic inside your subnet is unencrypted is okay? Then I don't think from that perspective you necessarily need to turn on MTLS from a service mesh perspective. It's it could be costly. It's an additional overhead and so on. So that's a concept you might have to think about if you want to actually activate. Can your actual environment handle the additional overhead? Well, TLS termination, stuff like that is relatively inexpensive from a compute perspective these days. It's still something that is going to eat up resources that you may or may not want to consume, or you may not have that much of. Because before you even deploy your application itself, it does deploy a sidecar proxy, a sidecar container inside your pod alongside your actual application. That will eat up CPU and memory as well. And so before you even get started, you might already be consuming 10% of your cluster resources just for the sidecar itself in the overall grand scheme of things, right? And the last point, and probably the most important one, especially with customers who are doing multi-cluster management in different environments on-prem, in different cloud providers, can we actually adopt this bit by bit? Because each cloud provider, each environment that you're deploying into may or may not, you may or may have already chosen a particular service mesh. And are you able to deploy that all across? Is there some way you can interconnect them with some of these features? Like maybe we have the same root certificate authority, so at least we get end-to-end encryption among the various different service meshes, but we'll have policy handled in those individual environments by its own service mesh that's running it in that. Maybe we have to do things like or having services join the mesh that aren't in Kubernetes, that aren't running in containers. Maybe they're just VM workloads. Does our service mesh provide that? And how do we actually adopt that as a next step? Okay, so these are dimensions to it. I would probably say, much like the in webinar 1, when we talked about network policies, choose a service mesh just to ensure that the end-to-end encryption is there. I know I just said maybe you might not need it, but it's a pretty handy feature. And if you are in a regulated industry, this will at least meet a pretty big check mark that you might not be doing today already in terms of ensuring, again, end-to-end encryption, and that traffic can't just be inspected at will, so to speak. Moving on to the idea of how do we actually, that complexity of, we have multiple environments, different service meshes. How can we just turn one on and be guaranteed that in the future, if we decide to change to another service mesh, how can we actually maintain at least that minimum sort of surface, that API, in terms of the 4 features we mentioned before, around observability, secure encryption, transit, traffic management, and the 4th one, I can't remember off the top of my head. So there is the SMI spec, service mesh interface specification. This is an open source specification that our team, from our DAS team that we acquired some years ago, have put out there. This is also something we donated to the CNCF Foundation, where it outlines the sort of basic interfaces that meshes in Kubernetes should probably have today. So this provides us a way to ensure that if we have policies in place, or if we set up TLS certificates, that we can gradually swap that underlying technology out of the box. The additional value of this, of course, is that it allows for a more streamlined ability to add functionality or tooling on top of these service meshes, right? So we don't necessarily have to have an Istio or console-specific implementation or Linkerd specific implementation of things. We can apply tools on top that know how to speak the service mesh interface, or at least understands we need to provide to the API and what we're going to get out of the API accordingly. So this is the additional value. We add additional ecosystem tooling on top. Our apps themselves can directly talk to the service mesh without, again, knowing what the underlying mesh is. And then to this point, we can actually be guaranteed that it is there in our infrastructure. We don't necessarily, as app developers, want to implement the service mesh itself. We don't want to go get certificates. We just assume that it's there and let the infrastructure, just like networking, it will just be there when we deploy our app. Sort of a segue on this, we mentioned sort of 3 biggest service meshes out there. There are additional ones out there like Kong. There are plenty in the ecosystem. We are also providing one called Open Service Mesh, which is a Microsoft implementation of the SMI spec, providing the 4 features before. And eventually it will be offered as a managed service within Microsoft and Kubernetes, or AKS itself, where you can, just like Azure Monitor, 1 click, activate, turn on, and it'll be in your environment. So the landscape, again, the big 3, I'm not going to drain this for reasons of time, and also the fact that you can we'll provide these decks for you after the fact, and you can read through it. But these are typically the big 3 that you would expect to see. Linkerd probably is the lightest service mesh out there. Consumes the least amount of resources. Easy, very easy. If you follow the documentation, very easy to get started on and start running. If you want something a little bit heavier weight in that sense, all the bells and whistles, the kitchen sink too, Istio is probably the one you want to go with. I probably wouldn't start with that one necessarily day one, because there are so many features, you don't know which ones to turn on, and it does consume proportionately more resources accordingly, right? And then HashiCorp console. If you already are working with Terraform and you're working with a HashiCorp rep, this is a good path to go down too, because they have a great engineering team and support team out there. Not only that, but I think if you're working with legacy environments where a lot of services are running on virtual machines, HashiCorp Console Connect does provide a way for you to have virtual machines join the mesh accordingly as well. So you get all the benefits of MTLS and the policy and ruling and stuff like that, but you don't necessarily have to deploy a container or run it in a Kubernetes environment. You could adopt or onboard a VM or some other machine that knows how to run the console agent on those boxes as well. Again, Open Service Mesh, it's our sort of implementation. It's available as a public preview add-on to AKS today. Essentially, it ensures that it's a managed service mesh, turn it on, and then it'll enforce MTLS and access control policies, etc., inside an AKS environment right away. And this will be part of also our Arc story in the future, that if you want an Azure Arc enabled cluster and you want to make sure that you have the same or similar service mesh across all, get pushed down and installed, this will be the one that we will be supporting in the long term. All right, so I'm going to actually kick it back to Kendall for a sec, because in this service mesh conversation, it comes up quite often in terms of the comparison between Dapper, which can do some service meshy type things, to an actual service mesh, and like when should I choose one over another, and that kind of stuff. So Kendall, I'll leave it to you to be the expert in there.
Yeah, no, Ray, I think that's kind of just what I wanted to emphasize on this slide is exactly what you said. So we see some customers who look at Dapper, the distributed application runtime, which is really just a portable runtime that runs as a sidecar for helping offload some of the microservice-based best practices to the sidecar instead of bringing them into your application code. Acts as essentially an abstraction layer over the the implementation you'll use of something like PubSub or observability tracing. And so that's what you see in the light blue box is some of the things that Dapper actually focuses on and helps codify in that sidecar runtime. However, Dapper also does provide some overlap with what a service mesh provides, things like MTLS, getting that distributed tracing with correlation IDs, things like retry logic. So that's from a resiliency perspective, but it doesn't really provide that traffic routing and traffic splitting. So that's where if you needed those features and pieces of functionality, then no, maybe Dapper alone wouldn't provide you what you need. But I think that this is going to be part of a bigger conversation in the next web series about like what is Dapper, where is its value. But I think it's just important to call out that as we go into that conversation, Dapper can be run side by side with a service mesh, or it could potentially provide you with the functionality you need. And as Ray talked about on that slide before, right? Like, do I need a service mesh? If so, why? I think that that's the conversation you need to have. And if Dapper meets a need and then can fulfill maybe the core baseline requirements of what you need, then maybe you don't need to go to the next level and have that service mesh to do some of the more advanced traffic routing features. So yeah, just wanted to call that out as we go into that conversation.
Great. Thank you, Kendall. All right. So the last little bit of the presentation, I want to talk about inter-cluster scanning. So we kind of touched on this in the first webinar, and this one it's going to be more around what to expect now in a Kubernetes cluster when it comes to scanning. And typically, this conversation goes hand in hand with the idea of antivirus or malware scanning. In a normal environment on each of our servers or each of our machines, we would install antivirus and malware software to detect whether or not something's been infected, or how do we actually quarantine that infection, and then how do we detonate or basically destroy that infection. Now, in a Kubernetes environment, because everything's ephemeral, our containers and presumably our nodes should be ephemeral. How does that actually work? Because the idea of them being short-lived and they live and die quickly should be essentially that remediation process, that detonation process that an antivirus software, malware software will do. So that side of things, we're kind of spoiled in that sense. It's going to handle itself in theory, right? Assuming we're rotating our nodes, just like we're talking about in webinar 1. Our containers are constantly being updated by the sheer principle that we're releasing often and things like that. We're being able to deploy new versions of our app very quickly and very often. And so we can actually, get away with that part of it. But how do we actually detect? How do we actually know whether or not our software, our well-crafted code has actually been compromised? Or how do we actually know if our nodes themselves have been breached by someone externally? And so there are a couple of things that we can do. So first in this list, I'm just going to talk about the control plane. So the control plane is separate. We manage that on your behalf. We kind of monitor it in part for some of these vulnerabilities or any attacks or any sort of access from the edge perspective inside Azure, and then we keep an eye on the control plane once it's actually deployed. But if you want to run your own tests in here too, as part of your strategy, take a look at things from AquaSec like KubeHunter or KubeBench, which will, first of all, from KubeHunter perspective, it'll try to send or do some malicious stuff to check to say, I can do this. These are things that we know are known vulnerabilities, etc., to go and check and see if your control plane might have some holes. And we kind of do the same thing on our side. This is something that you can do so that you can generate an audit report and send it to your stakeholders accordingly. KubeBench is another tool which also scans against your nodes and your cluster in general against the CIS or the Cloud Internet Security Group. I think that's what CIS stands for. Their sort of benchmarking or their compliance recommendations around secure nodes in the cloud. So when we move beyond that, so that's the control plane part of it, and then partially the node itself to check how do we actually scan and find those things, how do we report back, those will bubble up accordingly. So they can integrate into things like Azure Sentinel or into the third-party tooling itself, and they can send you like these hard reports to say, okay, and settings that if these vulnerabilities are in place, someone's trying to access privileged pods or run as root user, that you will get an alert. Or in some cases, again, the hard shutdown of things like we're just going to block it or kill that particular process because we don't want that, or it may just be an alert. Overall, in terms of intra-cluster scanning itself, there are things to keep in mind in terms of your nodes. We'll get to that in the next slide in terms of what will likely happen on nodes that you should be watching for, just like on any Linux server. In terms of constantly scanning your containers. So this is the big one, runtime scanning. So the time between we've pulled in an image onto a local node or from my virtual machine from a container registry. The container registry, like we're talking about in webinar 1, should be scanned every time it's being built, or at least pushed to the registry itself, and constantly check to see if there's any CVEs that have been reported or exposed accordingly. Similarly, on the actual nodes themselves of the that are running containers, how do we guarantee that those containers haven't been tampered with since we've downloaded it, since we've pulled it in from the registry, or even while it's actively running in memory on the actual node itself? How can we actually check to ensure that no one's trying to ask or request to be a privileged user or access the file system that they shouldn't, right? So these are additional intra-cluster scanning things that you should be aware of. This kind of goes above and beyond antivirus and malware because they're just kind of checking code itself, or checking for known external calls and things like that they can identify. The container scanning portion of it is very important because someone could have access to the node, which is another problem itself, but then hijack the container and done malicious things to it itself. Your other typical routes to this, not unlike any other environment, but typically not part of the monitoring logging solution that you would get an antivirus of your overall system, is to check the logs of your actual nodes themselves and the container logs themselves from standard error, standard out. There are intelligent tools coming out that will scan the logs over time to check for aberrant activity. It'll have like a AI or ML kind of baseline in terms of what should or what's the expected outcome on a day-to-day, and then it can see any spikes in terms of traffic or even access logs accordingly. And then last thing I want to kind of bring up is we talk about ephemerality. In a lot of cases, the customers, when it comes to intra-cluster scanning to check for vulnerabilities, tangential to that is the idea of a recycling policy, not only for your containers, meaning that might be part of your just deployment, your constant shipping of updates of your app, but also the recycling of the containers. Containers in general should not live more than X number of days or hours, or maybe they're a per process execution principle, so that if there is a compromise in place, your blast radius, your compromise time is snapshotted to just what you've laid out in that policy. Similar to that, your nodes themselves, the VMs, the virtual machines, possibly should not live more than, say, 30 days. So you might have a way to recycle out the node to sort of disinfect your environment quite frequently, because I think a typical compromise is in the order of like hundreds of days, if not like a year before it's even detected in most cases. But do keep in mind that if you are deploying or setting up an ephemeral lifecycle strategy or recycling policy, this will differ quite a bit between your stateless applications and your stateful workloads, especially if those stateful workloads are running the state or persisting the state inside Kubernetes itself. Okay, so this is a hot topic, probably something for a future webinar that we will delve into in terms of storage. So things to consider for scanning, things to take a look at, kernel exploits. All your containers on a given virtual machine share the same kernel, right? There are safeguards in place to prevent them from being able to break into the kernel and hijack a sibling or an adjacent container or process. But these are things that do happen. And so the tools that we mentioned before, Aquasec, Twistlock, so on, even Azure itself is coming out with Azure Defender that will do similar kind of things to scan the environment. Those are things to look out for, and that's what this tooling is being done. You don't want to be in the business of necessarily doing that. There are things like denial of service attacks coming from the containers themselves. Repeatedly opening and closing sockets is a big issue. It will eventually lead to, if you're doing it very frequently, to locking up your actual VM itself. Even if it's done from one container, doing it to the underlying VM to open and close sockets will lock up the whole node, and that will lock up all the sibling or the other applications running on the same virtual machine. And then the big things, of course, privilege escalation. Am I going to try to run or access my given node as root? And are we doing runtime scanning itself to ensure that even while running in process, is there anyone trying to mess around with the actual app while it's live? Tooling in the space. So this will be the last part in terms of the observability part. We did want to mention that these are sort of some of the big names, at least in the industry right now. Do take a look at them. I don't necessarily have a strong opinion of one over the other. They all do a great job. Some things might be like UI or integration with other tooling that you might already have in your environment, etc., or preference in general, but do have something like this deployed in your environment. Again, you might not be using it day one, so you can use they generally have a free or evaluation period of at least a month, if not multiple months. But this will get you started and get you prepared in terms of thinking about what this security or next level scanning should take, should become and how it should form. Okay, high level recommendations. Do turn on Azure Security Center. At least you get some alerts and some guidance in terms of like, is this a critical issue? Is this like a soft yellowish, or are you green compliant kind of thing in terms of how you view your cluster? Policy enforcement. So, like what Kendall covered in the first section, can we deploy AKS in a given region, right? Do we have like GDPR issues? We can't deploy the cluster over there because it's going to have control data or application. All that can be controlled inside the policy enforcement. Great thing to turn on, very easy to do. You can script with the ARM templates. Setting up egress traffic flow. So this one is a little bit of a bigger topic in terms of how you want to control this. But yes, you probably should be setting up at the very minimum things like egress traffic, outbound traffic rules through a firewall. You don't want your worker nodes, if your worker nodes do get compromised, you don't want it to make external calls to something else. In some cases, this might be something like data exfiltration. The service runs inside your network, and you don't want it to be able to read from your database, which is one problem. But even if it did read from the database, it can't just make an arbitrary call out to the public internet and send that data to a malicious actor externally, right? And capture AKS control plane logs. This is a big one. Control plane logs will eat up a lot of storage, right? It's very chatty, and so you should be capturing the logs related to AKS on the nodes, the control plane itself. It should be sort of a triaging or trying to figure out what errors have occurred instead of constantly having it on. And then use from the authorization and identity or auth-n and auth-z perspective, use AAD where you can, not turn it on right away, and then use Kubernetes RBAC at very minimum as well. If you're not going to use AAD integration with your groups and users within your Active Directory. And then pod identity, which is going to be the next, I think personally, the cool thing that'll go on is that you can actually give your apps themselves an identity. And then at that level, get very granular in terms of what resources they can or can't access, even within Azure itself. Okay. Cluster practices, again, securing the API server and cluster nodes themselves, a big one. So control plane, private control plane. Won't train this all just for the sake of time, but do keep these points in mind and do ensure that there is security scanning. We mentioned that before, and that's a huge hot topic. All right, I'll leave this one for homework for the audience. If you're watching this or made it all the way here, this is generally sort of a baseline footprint of what this should end up looking like. Additional Q&A we'll cover in the Git repo. So we'll post the questions that were in our live webinar in there as well, along with the answers. And if you do have additional questions to ask, file a GitHub issue. We'll get you there, or fire Kendall and myself in a message on Twitter or GitHub as well. Okay. I guess Kendall, this is probably more for you to.
Yeah, sure. So just as a follow-up, make sure that you keep in mind we have the AKS office hours. They happen bi-weekly, Thursdays, 11 to 12 CST. So if you're interested in just having further discussion around these topics, we'd love to host you, to have you. If there are questions around roadmap, definitely recommend coming on and joining us when the product group is on. And so all of this is housed in our GitHub repo, which we'll link in the notes below. And also, if you're on our channel, then most likely you're able to access the playlist that's associated as well. So thank you all so much for joining. We look forward to seeing you in the next session that's happening on the 28th on Wednesday, all about kind of workload. We're definitely going to talk a lot about Dapper, some about Kata, and some of the other cool open source projects. And then obviously we'll post the list of resources here in the GitHub repo. So, once again, thanks for joining, and we'll see you in our third and final session coming up soon.
Thanks, everyone.